Hi, welcome to my talk on the effects of image realism on the stress response in virtual reality at VRST 2021. My name is Sebastian, and I will present this work on behalf of my co-authors Nelly Klaassen and Wilco Heuten. Currently, the German health system is under strain, and there are thousands of open nursing positions, and this number is projected to rise to 63,000 open positions by 2030. This is, at least partially, due to the fact that the profession is very stressful. While nursing schools have made use of concepts such as stress inoculation to teach the handling of stressful situations, their simulations lack realism. On the one hand, repurposed classrooms are not an ideal simulation environment, and on the other hand, role play is often not taken seriously. Furthermore, the access to specialized skills labs is not guaranteed. In order to support the teaching of safety-critical and stressful situations, we want to provide a cost-efficient simulation system which can be used to develop coping resources. The idea is to use VR, as it has been proven to be useful in lots of domains, such as entertainment and education, but even more so in the simulation and training of safety-critical situations. It has also been shown to be able to successfully inoculate stress in humans. However, graphics and realism are a big factor in the cost of developing such a software, so this must be taken into consideration. Before we can dive deeper, we need to understand the terminology a little better. In the context of our work, stress describes the adaptive reaction of an organism to handle internal and external conditions, so-called stressors. We differ between negative stress, such as fear or worries, and positive stress, also called eustress. The nervous system reacts to these influences to adapt, a reaction that is often called fight or flight. The reaction is exhibited through the psyche, the body, and the behavior of the subject. Another important concept for stress inoculation training is immersion. Immersion describes the technical capabilities of a system to stimulate the senses of a VR user to make them feel present in the artificial environment. It can be split into two components that contribute to a realistic feeling of presence, one being the place illusion, the feeling of really being in a place, and the other being plausibility illusion or coherence, referring to the feeling that the situation is actually taking place as depicted. These two concepts together lead to a feeling of presence, or more specific, to the illusion of complete submersion in VR. Although immersion is based on 6 different dimensions, we focus solely on vividness, as it relates to those qualities of a system which we earlier identified as being a rather important cost factor during development. Within our study, we use different qualities of simulation and lighting conditions to see if they have an effect on this reaction to a stressful scenario. The related work in this field has come to differing conclusions. Dima et al., for example, have reviewed literature on impact of presence and perception on the emotional reaction and found significant changes in the stress reaction depending on immersive factors. On the other hand, Fellenhofer and Gromer show in their respective research that presence is the prerequisite for a response, implicating that a threshold of presence is required before a subsequent stress reaction can occur. Other research have stated that it is, to this point, unclear whether the stress response and the amount of presence are related in any way. This leaves us with 3 distinct possibilities. The first, the level of presence influences the strength of the reaction. The second is that the presence serves as a threshold. And the third possibility is that, if correlations are found, these are coincidental and that stress is independent of presence. Based on our goal and the related work, we want to investigate 2 research questions. Do different degrees of immersion lead to differently strong stress responses, which would be in line with the first possibility I just described? And secondly, can, by means of visual acuity of a clinical ICU, a stress response be invoked that is of equal strength as in reality? To answer these research questions, we designed a within-group lab study to which we invited 19 participants. We designed 4 scenarios with decreasing visual acuity, or what we call image realism. This is our independent variable. Subjects have to work on typical tasks from the environment and are being subjected to 2 different stressors which are also typical to the ICU environment. The order of tasks, stressors, and scenarios were randomly distributed between participants. Before the experiment, we took a 2-minute baseline recording of vital parameters. During the scenarios, we recorded heart rate, breathing rate, and the galvanic skin response. Between the scenarios, we measure the stress level in a subjective way using the PSQ-20 questionnaire and a custom 5-item Likert scale. Additionally, we use the iGroup Present questionnaire in order to assess the subject's presence during the experiment. With this study design, we examine these 2 main hypotheses with respect to the research questions I presented earlier. The first hypothesis states that differing degrees of image realism evoke differing stress responses, and the second hypothesis states that the visual acuity of a virtual ICU can elicit a stress response that is of equal strength to a reaction to the real world. To give you a better impression of what different scenarios look like, let's have a look at these screenshots from within the virtual environments. As I mentioned, our research focuses on vividness, more specifically the image realism. Hence, we decided to forego the implementation of sound or animations. SC2 has the highest visual acuity, with real light and shadows, as well as the design of the objects within the environment, such as the bed and medical devices. SC1 is the first level of abstraction of the whole environment. We removed shadows and textures and used abstract forms to represent the objects in the environment. The color palette was kept the same as in SC2. In SC0, we removed the whole context in line with research from Rose et al. In this scenario, the only objects in the environment are those that are relevant to the given tasks. We have also implemented the same experiment in an ICU lab on our premises to be able to compare the stress reaction of the virtual scenarios to a real environment. However, here as well, no sound was used. Looking at the results of the IPQ first, we can see the difference in visual acuity indeed led to significantly different results in 2 scales for every comparison and spatial presence at least between scenario 1 and 2. Based on these results, we know that the manipulation of immersion was successful. We can see a high scatter throughout the objective data, which might be explained by different levels of experience not only in the profession, but also in the handling of VR. Between the scenarios, we have significant differences in the heart rate and breathing rate from each scenario to the baseline, but not within the scenarios. The GSR measures show a significant difference between the baseline and the real scenario. This table provides an overview of the increase or decrease per measure between the scenarios. With the exception of GSR, all measures point to an increased stress level from SC0 to SC1, but a decreased level from SC1 to SC2. This may be caused by a higher abstraction level in the first scenario in comparison with the second, which would mean that people feel less stressed in an environment that is more real, or rather an environment that they know. In the subjective measures, we can also see a high scatter in the data. There are no significant differences in between the scenarios, and neither when comparing baseline to the scenarios. However, the median of the PSQ may hint towards a stress induction. In this table, we see the general scale of the PSQ20 decreasing with higher image realism when looking at the mean values. However, the requirements subscale shows an increase in both comparisons, whereas our 5-point item Likert scale shows a decrease from SC0 to SC1, but an increase from SC1 to SC2. At the same time, the median of both the general and the requirement scales of the PSQ imply an increasing stress from SC0 to SC1 and a decrease from SC1 to SC2. The median of the Likert scale does not change from SC0 to SC1, but rises from SC1 to SC2. There is no clear development in the stress level according to the Likert scale. Nevertheless, our data indicates successful yet differently intense stress induction in each scenario, and thus we accept H1. This might seem counterintuitive, as one might expect an increasing stress with increasing graphical detail, but stress levels are indeed different in each scenario. As an interim conclusion, we note that a correlation only exists when checking the medians. The Likert scale does not seem reliable, and neither does the PSQ, as it was developed for longer periods of time and not for momentary stress perception. With respect to the second research question, we can neither reject nor accept H2, since the data is too inconclusive. Further research is required in order to collect more data to investigate the hypothesis. Nevertheless, we believe that in future studies, the realism should be held as high as possible in order to maintain a strong feeling of presence. Our results might be depending on the amount of job experience and knowledge in VR, so a more diverse and larger sample is advisable. As a limiting factor, we have to note that we could not find a stress questionnaire that is aimed at the momentary stress perception. This might have had an influence on the subjective results. Furthermore, we got the results from the questionnaires in real life in between the scenarios when they better should have been answered in VR directly. For further research, differences between in virtual and in vivo scenarios should be avoided, and baseline recordings should be taken in standing positions as to minimize the differences in measures that are based on cardiac activity. This might also explain the differences of subjective and the objective results. In this study, we present research on the influence of image realism and the stress response of users. By varying the vividness of our virtual environment to different degrees, we elicit measurable and different stress responses from our participants. However, as per the subjective measures, the image realism does not have a significant influence on the stress reaction, yet there is a tendency to higher stress in more abstract scenarios. A qualitative reflection shows that users prefer a more realistic environment for their training purposes, leading to our recommendation that although high visual acuity is not essential for stress induction, it is recommended for higher immersion. With that, I thank you for your time and I'm happy to take your questions.